All right, today's lesson is on 8.6, comparing linear, exponential, and quadratic functions. Now remember from previous lessons, a linear function can be written y equals mx plus b. That was the straight line. An exponential function was where the x variable was the exponent. A quadratic function is what we've been dealing with in this unit, polynomial with a degree of 2. All right, so for example 1, we're going to be looking at graphs of linear, exponential, and quadratic functions. Part A, I already plotted the points, and then by looking at this graph, it looks like there's an axis of symmetry. So it looks like if we picture where that middle point is, which could also be called a vertex, the points on either side are reflected over that axis of symmetry. Because it has an axis of symmetry and because it has a vertex, we know that we can call that a parabola, which means that example A is quadratic. All right, so I also already plotted the points for part B just to make this go a little bit faster. There are 5 ordered pairs, and you notice all 5 ordered pairs go in a straight line. They also have a constant rate of change. So from each point, it goes up 3 over 2 to get to the next point. Remember, that's what we also called slope. So because it has a constant rate of change, because it has a slope, we're going to call that linear. All right, in example C, again, the 5 points are already plotted, but it looks like the distance between each point vertically doubles each time. So it starts at 1/2, and then it goes to 1, then it goes to 2, 4, 8. It's multiplying to get to the next number. It has exponential growth. It's an exponential function. All right, so the core concept of this lesson is that you can use patterns between consecutive pairs to determine which type of function models the data. So a linear function, the differences are going to be constant. It's going to add or subtract to get to the next point. An exponential function has consecutive y values have a common ratio. That's where it multiplies or divides to get to the next number. And then a quadratic function, the second differences are constant. And I'll show you a little bit more about what that means in the next example. But we can also tell that a function's quadratic by looking at its graph. It has a parabola. The values are going to reflect over the vertex. For now, we need to remember linear function, constant rate of change, it has a slope, and exponential function has a common ratio. All right, so here we're going to tell whether each table has a linear, exponential, or quadratic function. If you notice, the x values in each of the tables each increase by 1. So we're going to focus more on the y values. Let's look at table A. The y value from 11 to 8 moves down 3. It subtracts 3. Then from 8 to 5, it subtracts 3 again. 5 to 2 subtracts 3. 2 to -1 subtracts 3. It has a constant rate of change. It's subtracting to get to the next term. We call that linear. All right, for the table in B, the y value to get from 1 to 2, we could explain as it adds 1, or we could explain as it multiplies by 2. So then we check our next difference to see which one it's similar to. To get from 2 to 4, it does not add 1, but it multiplies by 2. So we see between every y pair, it's multiplying by 2 to get to the next term. If it multiplies, it's exponential. That is a common ratio. All right, table C is where it gets a little tricky. So we're going to look at the difference between each y value. From -1 to -2, it goes down 1. And it's going to go back up 1 to get from -2 to -1. From -1 to +2, it's going to add 3. And then from 2 to 7, it adds 5. So now, what the second difference is called with quadratic functions is going to be the difference between these numbers. So now if we look at the difference between each of these numbers, to get from -1 to +1, it adds 2. To get from +1 to +3, it adds 2. To get from +3 to +5, it adds 2. This is what we call our second difference. So because the second differences are the same, it has a constant rate of change there. This is a quadratic function. All right, so summarizing the notes for today, when you are given a graph to determine if it's linear, exponential, or quadratic, you can look at the shape of the graph. Linear is going to be a straight line. Exponential has that exponential curve, and quadratic looks like a parabola. When you're given a table of values, you can determine if it's linear, exponential, or quadratic by looking at how the y value changes between each x value in that function. Linear is going to have a constant rate of change. It's going to add or subtract to get to the next term. Exponential is going to multiply or divide to get to the next term. And quadratic has a constant rate of change between the second differences, which means the second differences are going to add or subtract.